Hi, everybody. We're going to be together for a little bit. So I really appreciate you all coming to this workshop today. I think, so are we a little early or is it the right time to start? We're good? Okay, let's cruise. All right. So to get started, Rosa gave me a lovely introduction, but just to reiterate, my name's Kayla. I work at New Relic. If you've ever installed the New Relic RPM gem, that's the project that my team and I maintain. And then I'm also a maintainer on the two OpenTelemetry Ruby repositories. And we'll be using code from both of those repositories today. So OpenTelemetry, Rails instrumentation, they're all very vast topics. So just to kind of narrow it down, today what we're going to talk about is how to add OpenTelemetry to a Rails app. We're going to talk about core signals, traces, metrics, and logs. We'll talk about how instrumentation works as well. We're not going to get into some of the more advanced topics related to OpenTelemetry, including the collector, baggage, span links, propagators. We're not going to do too much troubleshooting, like how to use this data. And we're also not going to talk about how to choose a backend for your OpenTelemetry provider. So now that we've kind of set those expectations, so our agenda, first I'm going to give a lecture on the basics, make sure we're all on the same page in terms of the vocabulary. Then we'll start adding OpenTelemetry to a Rails application. If you guys are on the Slack for this event, there is a Slack channel specifically for this workshop. I believe it's called 2025 Event Rails OpenTelemetry Workshop or something like that. And on there, there's a pinned post with a link to a repository that we'll go through and add things to. So if you haven't cloned that, I recommend cloning that during the lecture, though I'll share links as well on the screen when we get to that point. And then we'll have a 10-minute break halfway through. There is a break slide. We'll see if it all syncs up. But then we'll continue with the app adding things, and then we'll kind of close with a little bit about ways to continue engaging with OpenTelemetry and learning more. I also wanted to note, take care of yourself. 2 hours is a long time. It's in the middle of a long conference overall, so if you need to get up and leave or get water, there is also a gist that's linked in that Slack channel that I mentioned, and so that should help you kind of jump back in and catch up on any steps that you might have missed. All right, so let's get into kind of the lecture termsy part. So the first thing is, what is observability? I like to use this example of a car. So you can be driving a car and maybe your check engine light comes on. And that's usually cause for some sort of concern. You want to know more. And you'll generally take your car, if you're not skilled in mechanics like me, to a mechanic. And they might pull out one of these, a code reader. And this is something that you can plug into your car, and the mechanic will usually get some sort of number that is very specific to the problem that is happening with your car and will allow them to help diagnose what's going on. Observability does this for applications. It's a practice to help understand the internal state of your system based on its outputs. And it's achieved by collecting data, or also referred to as telemetry. Now, there's a lot of debate in the observability monitoring world right now about terms and which terms are best. So, monitoring is kind of seen as the old way of doing things. You know what's happening, you know what could be problems, and you track for that. You have very predefined metrics and dashboards, and maybe we'll deploy, changes to your application with additional logging and things if you have problems. Observability tries to take things a step further so that you know why something is happening and not just what is happening. It tries to have a broader depth of information so that you can answer any question, including unknown unknowns. And the idea here is to become proactive so that the data you already need has been deployed and there's fewer of those incidents where you need to deploy another copy of your app to help troubleshoot things. And this book that I've linked at the bottom, Observability Engineering, goes in way deeper on these ideas, and I highly recommend it if you're interested in this topic. These are some traditional observability vendors. So if you've installed maybe software from one of these companies into your application or just seen them around, their business is kind of in this observability and monitoring space. So traditionally, the way that observability would work is that you would download a vendor-specific library. We call them agents, but agents are now becoming many other things, so we'll see if that sticks. And then, that vendor-specific library gives you a strong baseline of what's called instrumentation, different telemetry that is connected to libraries that you use. But inevitably, those vendor-specific libraries don't cover everything that's unique about your domain. And so you'll need to add API calls to get additional telemetry. And they're also usually vendor-specific. And then that code goes to a single backend where that vendor can visualize your data and store it and also charge you whatever they want in order to have those visualization and storage opportunities. So you can very easily get locked in. And OpenTelemetry is here to kind of solve some of those problems. So what is OpenTelemetry? I like to use this example of the many, many cords that at least I have in my drawer for all the different electronics that I have. When you have one cord per one electronic device, things can get really messy, especially if you lose that cord. The way that traditional observability vendors work kind of feel aligned to this, where you need each one of their tools and all of their APIs inside of your application, and it's kind of difficult to decouple the two. OpenTelemetry is trying to be a little more like USB-C. We're moving to a new standard so that hopefully we only have to have one cord for all of our devices, and it's ubiquitous. So OpenTelemetry is this vendor-neutral solution. It's open source, and it's a highly open source project where people from companies all across the world, both observability vendors and what we call end users, people who install the vendor's tooling or observability tooling into their applications. And there's a lot of checks in place to make sure that not a single company ever gains kind of a monopoly or control over the project. It's highly modular and customizable. Some of those things that I mentioned we're not going to cover at the beginning allow you to really tweak the data that you store and send. And we'll get into a little more about how the OpenTelemetry Ruby project is structured to allow you to install only what you absolutely want. There's also a public specification and semantic conventions. And those things are also being defined in this open source sense, where it's a very democratic conversations, everyone can go. But the goal of this project is to create a new standard for observability information. It wants observability to be built in and ubiquitous and not something that you add to your application once it grows to a certain size. It wants you to have it in your application on day one so that you can start that practice of keeping an eye on your application using telemetry. It also deals with the collection and standardization of the data and not the visualization and storage. So those traditional observability vendors that I showed you before, now they're needing to compete on their storage costs and their visualization strategies, the kind of features that they can build on top of the data, rather than the data that they collect. So to kind of reiterate this a little bit, there are pros and cons on each side. Some of the elements with the vendors are open source. OpenTelemetry is fully open source. The vendor code is usually a lot more mature, and so it will likely have bugs worked out or a deeper feature set or more instrumentation. OpenTelemetry is still growing and developing. But you can get locked into a product, and it can be difficult to walk if your bill is no longer compatible with what your company can afford or wants to pay for observability. OpenTelemetry is vendor neutral. Vendors, and I guess OpenTelemetry, they both have their own configuration options, and that's well documented. But with vendors, there's a single company driving the effort, whereas OpenTelemetry has many companies coming together, which can create different ideas. I think one of the biggest differences between the two is that vendors have in-house support teams that are often paid really well and available constantly. With OpenTelemetry, you have maintainer support. And so you have people who are working in the open source. It's not usually their first job. It's kind of their second job or another tag on to what they do every day. So the turnaround time for pull requests and support tickets can be a lot longer. And you may be the best solver of your problem. And perhaps your PR comes in and that's what actually solves the issue. So we're going to talk a little bit more about OpenTelemetry and see how you can use it in your Rails application. The Ruby project in particular is what I've been working on, and the rest of this will come a little later, but I hope you have a better sense now of what this project is like. So let's get into the data that helps make observability possible. We have these core signals, is what we call them, which are just kind of the data types to help with this observability practice: logs, metrics, and traces. Sure, most of you have heard of logs. They're the oldest form of telemetry. Essentially, they're a time-stamped message. They may be structured, they may be not. They're very useful for debugging specific issues and kind of finding a narrative around whatever problem you're facing, but they are difficult to sort and correlate. Metrics are measurements of your system over time, usually some sort of string that it's attached to a number that gets recorded at a certain interval. OpenTelemetry metrics are kind of unique in that they have what's called dimensions, which basically means they have attributes, so you can go further into organizing your metrics and kind of sorting through them. They're great for looking at trends, anomalies, response time, and system health. Traces are the newest telemetry on the block, though they've been around for a while. You can think of them as an end-to-end journey of your request through your system, where every step in that journey is a span. So when you file up your localhost 3000 on Rails and load that first page, it's not just action controller, it's action view and your models and everything like that, and traces will capture each stage of that process. They can also be distributed across services, which is really helpful for the microservice architecture that many companies have moved towards, so that you can see how your services interact. I would say a downside to tracing is that it's difficult to collect all of the traces that are possible, so your traces may be subject to sampling, which means you might not have every single request that's recorded, just more of kind of a standard of a request, and trying to figure out what data is the most meaningful out of all those possible steps can also be tricky. So those core signals, they end up getting emitted to your application through what we call instrumentation. So instrumentation is that code that records the telemetry. In OpenTelemetry, semantic conventions help define what should be captured so that there's a standard that exists across similar types and categories of libraries and also across languages. And then in OpenTelemetry, there's APIs that you call that collect the data that are the exact same APIs that you would call in your application if you wanted to add any custom instrumentation. Okay, so that's the lecture part. It is time to take out your laptops if you want to follow along. We are going to look at an observability backend to kind of see how our data comes through. The application that we're going to use here is linked in that Slack channel that I was telling you about. You can clone it with this command if you'd like. But does everyone have access to the Slack channel? Is there anyone who doesn't know? Okay, cool. So what we're going to cover in this portion is we're going to talk about configuring the SDK. Then we will get into instrumentation, custom spans and attributes, and then we'll talk about metrics, logs, and at the end, hopefully we'll have time to get a little deeper and talk about active support notifications and add our own subscription for one. The way that this is going to work is that we'll make a change, we'll talk about the change, I'll have some slides for it. You will start or restart your server, and there is a traffic script inside of the application that you can click, that you can use, or you can, open up a UI in your browser and click around there to generate some traffic. Then we'll hop over to the UI, and these are all steps that you could do in your own application. There are a few, scenarios where we're updating specific methods inside of this app, but if you wanted to think about maybe what might be a good fit for your application and do the same things there, that's also completely fine. The app itself, so in this repository, it's Rails 8. It's running Ruby 3.4.2 because I forgot to update to 3.4.4. It's a very basic CRUD scaffold. There's very little extra on top of it. It's a hike tracker, so you have users and trails, and an activity belongs to a user and a trail. I think trails also have comments. The majority of this is going to be focused on the activity resource, so the activity models and controllers. There are also 2 directories in the home of that repository. There's the hike tracker original and hike tracker instrumented. Original is what we're going to be updating together. Instrumented is like the answer key. So if you don't want to type everything out, you could copy and paste things across. There's also a gist that I linked in that Slack channel that has each of the steps we're going to follow in the code, so you can also copy and paste those if that's a little easier. And then that traffic generator script that I mentioned, it's simple. It's just making curl requests. And we have some kind of built-in errors that exist in this application, so we can take a look at those as well. But it's just meant to be something very simple that will just hit the index and show pages. So I mentioned this before, but just remember the instrumented version of the app has the answers if you need that. So the next part is about our telemetry destinations. We have our app. The app will generate telemetry. We need something to view that telemetry. You can choose any vendor. If you're already working with a vendor, I'm sure they have some great documentation about how to connect OpenTelemetry to your app. I'm using New Relic because that's what I'm most familiar with. And they do have an opportunity for you to sign up for a free account. If you do that, you will need a license key in order to follow along in the UI. And here's a link to the other vendor options if you want to go that route. And that link is also available in the gist. So if you need to sign up for a New Relic account or another vendor, you can do that with this link for New Relic. And then if you do sign up for New Relic, after you log in with your password and everything, there is a place for you to generate and copy your license key up on this top right-hand corner. So I'm going to assume we're all, or I guess, is everyone good on the observability vendor situation? Do people feel, okay, cool, nice. The Ruby version is a suggestion, not a requirement. If you don't have 3.4.2 installed, just change your Ruby version file. As long as you have something 3.1 or above, that should work. All right, let's get into it. So CD into the workshop, and then CD into Hike Tracker Original, since that's where we're going to be updating things. You can run bin setup to bundle if you haven't done that already, and it will also prepare your database. I recommend that you run DB seed so that we have some data to play around with. Otherwise, your curl requests in the traffic script will be very sad. Cool. Okay, so let's get into tracers and exporters. So OpenTelemetry is set up in such a way that every single part of it is pretty much in its own gem. And right now, the main OpenTelemetry SDK and the main OpenTelemetry API gems only include stable code. And that's our plan moving forward. Right now, the only signal that is stable is traces. Metrics and logs are still experimental, so they live in their own gems. So the first 2 pieces we're going to add is the SDK, which is what you need to generate traces and also run some basic configuration on your app. And then the OpenTelemetry exporter OTLP. We'll talk a little bit more about that in a second. So the SDK, the way this works in OTel, it installs the API and it's an implementation of the API. So the API code in OTel is pretty much blank. You kind of just see the name of the method and the arguments that are required. Nothing else usually goes into it. You need an SDK to actually generate the information. And the reason why OpenTelemetry did that is they have this vision that there could be many possible SDKs as long as they all adhere to the specification that are doing different kinds of things. So the SDK, the other thing that I wanted to point out is that instrumentation only calls the API. It doesn't ever require the SDK. so that way you can have that kind of modular SDK experience. The exporter is what converts the data into OTLP, which is OpenTelemetry, the OpenTelemetry protocol. So OpenTelemetry has kind of established their own standard of the way that data should look. It is just pretty much done by protobuf files. The gem that I suggested everyone to install sends the data to a configured endpoint using HTTP. There are other exporters available if you would rather take that approach. Zipkin and Jaeger are two other open source options that we're compatible with. There's also a console exporter, so if you don't want to use a backend and just want to see data come through the console, I'll show you in a minute where you can make that adjustment. We also have a gRPC implementation, but it's experimental, so we haven't released it as a gem yet. It needs some testing, so if anyone's interested in writing gRPC testing, that would be very welcome. Cool. So we have our gems installed. The way that we configure OpenTelemetry and add it to our application is by creating an initializer. That's the most common process. Inside of your initializer, you're going to call OpenTelemetry SDK configure. This has a ton of options, but we're going to build on them individually. The configure method does a few things. So this is kind of more about the structure of OTel and how it works. It will create and set what's called a global tracer provider. And this provider model is kind of consistent across the other signals as well. The tracer providers have an entry point for the API, they provide access to tracers, and they keep track of span processors. So tracers are the things that create spans. Span processors are things that kind of batch up the spans or alter spans to prepare them for export. There are other things that happen in this configure method too, but they're not really relevant to what we're doing today. Oh, and I have a slide about this. So so tracers create traces. There's one tracer per scope. So every instrumented gem has its own tracer. Sometimes inside people's Rails apps, they will choose to create one tracer per area of their application. Sometimes, by general resource or theme. Sometimes all of their models have a tracer, all their controllers have a tracer. It's kind of just whatever dimension, whatever way of slicing the data makes the most sense to you. You can put everything in a single tracer, and that's what we'll do today. I think everything about span processors is pretty similar. So by default, a batch span processor is attached, and what that does is it sends your spans to an exporter on an interval, and it will start dropping spans after the max size for that batch is reached. This is what that code looks like in the SDK. You do not need to add this, but a processor has an exporter, and they're connected, and then you add the span processor to the tracer provider, and that's how the exporter ends up getting linked with the tracer provider. This is important for you to know if you want to eventually configure OpenTelemetry to do other things. You can add your own span processor. You can have as many span processors as you want. They are processed sequentially based on the order of arrays, so the order that they're added, but you can have multiple exporters, which can be really handy if you also want to send your data to multiple backends. Maybe there's multiple vendors that you want to visualize your data with. The next thing we're going to do is we're going to configure with some environment variables. So right now, there is a lot of configuration that's kind of standard across different languages in OTel through environment variables. The Ruby implementation also has that configure method we looked at earlier. There is a specification for file-based configuration coming soon. So in a YAML file, you'd have the ability to do some more specific configuration. And with these environment variables, for the workshop, I would recommend just adding them to your initializer file at the top above the configure call, but you can also pass them on the command line if that's easier. So what we're going to do here, this is connecting us to the New Relic endpoint. If you're doing something with a different vendor, they probably have a different endpoint headers situation. So the endpoint is specific to New Relic's OTLP data. And then the headers, you just need to make sure that you pass your New Relic license key after API key, no spaces. And those two things should be all you need to do to start sending data to New Relic. I mentioned before, you can have more than one exporter. You can update this OTel traces exporter environment variable to send to both the console and the OTLP using this example here. But if you don't want to send to the console, by default, it will go to OTLP. So you can eliminate that environment variable entirely if you want. The console output can be very noisy, but it can also be fun to see the raw data. Oh, and this is what it would look like if you were going to pass it to your Rails server line. But we will add more and more environment variables, and I'm not going to continue having examples for this. So back to our configure block in our initializer. The next thing we're going to do is we're going to add some details for our application, including the service name and the service version. So we can call our app hike tracker. That'll make it easy to find in the UI, and give it a version number if you want. This could be maybe like a build number in an actual application. I think you could also use Rails application name here if you didn't want to have a string. So resources are the representation of the entity producing the telemetry. They don't really have their own like data type that comes through. I like to think of them as just like a bucket of attributes that get attached to the other data types that we're already sending. And so then they create pretty consistent attributes across all the signals, which help with that correlation when you're trying to solve problems. And in the future, this could be changing. Like I mentioned, OTel is still very much growing and changing, and there's talk of adding an entity that would be kind of in addition to a resource. All right, we have the foundation down. If you were to start up your application now and start generating some traffic, you would see nothing in your backend. Because up until this point, even though we've installed things, we don't actually have any calls to the API to record telemetry. So to make it easy on ourselves, we're going to use this gem, OpenTelemetry instrumentation all, that you can add to your gem file. And what it will do is it will install all of the available instrumentation gems that the OpenTelemetry Ruby contrib repository has. We have a lot of things, for Rails and different popular HTTP client libraries, background jobs. I think most popular gems we have instrumentation for, and we're always looking to add more if folks are willing to help maintain the gem after they contribute it. So yeah, we talked a little bit about instrumentation earlier, code to add telemetry to your application. Like I mentioned, it's available as individual gems or as an all gem. I'll show you an example for that in a second. And there are three main strategies that instrumentation authors use in order to get this instrumentation. They're called monkey patching, publish subscribe or pub sub, and native instrumentation. Monkey patching is usually done through module prepending these days, but if you work on an ancient Ruby agent like I do, you also have alias method chaining. Module prepending is basically like cutting to the front of the line. When you prepend to the module, your code is going to go first and also potentially last in the full ancestors chain. Alias method chaining is kind of used for instrumentation by renaming the original method to something like uninstrumented, redefining the original method name to include your instrumentation code, and then making sure that both of those aliases are available so that way you're kind of tricking the computer into thinking that your instrumented method was in fact the original one. Monkey patching is the riskiest form of instrumentation because the APIs that you patch can change, and we're starting to see it as kind of a last resort as better solutions are built in. If an API that you patch can change, your data is not going to get sent anymore, or sometimes it'll throw an error in your agent, and that could potentially crash your Rails application, which is the thing I have nightmares about. So here is an example of monkey patching using module prepending. This is the MySQL 2 gem. This is a gem that the OpenTelemetry instruments directly. And in this query method is kind of the central point for most queries that are made by MySQL. We try to find those like as few methods as possible to add instrumentation to. In OpenTelemetry, that looks like calling this patch client method that runs when the instrumentation is getting loaded, and we prepend a new module onto the MySQL client. So that will change the ancestors chain to add our OpenTelemetry instrumentation in front of the MySQL client. Now what that actually looks like as instrumentation is that we have defined the query method in our patch, and we're calling a tracer that was created specifically for this instrumentation, and then calling in_span, which accepts a block, passing it attributes that have been defined by semantic conventions, as well as this span kind value, which kind of helps you organize your spans into client and server and different messaging concepts. And then we call super, so that way everything goes back to MySQL 2. In this situation, we don't need to do anything after we pass the baton back to the original code. And your span will end when super is finished, and then our end is called. Native instrumentation is where OpenTelemetry really wants everybody to go. The idea is that you add APIs directly to the library so that the library authors are paying attention to what needs to be instrumented and thinking about that, and including that as part of their maintenance. This would move towards OpenTelemetry's goal of ubiquity. And the way that looks, I think right now, the example that I always think of is Elasticsearch. The Elasticsearch Ruby gem boils down to this Elastic Transport Ruby gem, which includes this method perform request that almost everything you're going to do with Elasticsearch goes through. So they are calling these OTel APIs specifically. They have some sort of configuration that makes sure that this code doesn't run if you're not trying to use OpenTelemetry. But you can see here, Elasticsearch is now working on updating the conventions and making sure that the attributes are accurate instead of the OpenTelemetry maintainers. The pub submodel is what Rails uses with active support notifications. It's great because there's public APIs, which gives greater confidence into the consistency of methods. And it may not capture everything that instrumentation authors want, which can be the downside. I think there's a few things in Rails specifically related to models that aren't quite captured by this. And so we will usually use monkey patching to take care of those edge cases. So inside the Rails code, the way that this looks is calling active support notifications instrument, and then you give it some sort of event name. So this is an example from the Rails API. You just call render, and then you pass some additional information to it. And inside of the block, you actually call the method that ends up getting called. So very similar to the monkey patching, it's just defined here. For process action controller, which we're going to use a little later, this is what the code actually looks like. And when you call super on line 76, that is when we pass the baton to the original process action controller method that is doing the things that we know and love. The subscribe method is the next part of it. So the instrumentation authors will subscribe to the notifications so that whenever those events run on the event loops, we can get this data and add it to the telemetry. So with process action controller, we want to know how long that part of the request took. So we'll usually grab the duration. This is kind of a trivial example where all that happens is we log an info message, but this is essentially how it works. Okay, so now that we know a little bit more about how instrumentation works, we're going to add the instrumentation to our application. You need to add a call to use all to your configure block in the OpenTelemetry initializer in order to do this. And this will install all of the compatible gems. If you don't want to use all and go blindly into that, then instead you can call config use, but you have to specify every single gem that you want to install in this case. So it's kind of up to you as to whether you want more detail, less detail, more control, less control. Going back to the previous slide, there are options too to configure every single one of those gems. And for rack, if we want to play around here and add a little bit of configuration, you can update this to allow some response headers that will then get included on your rack traces. And we'll take a look at those. All right. So if you were going to use the use method instead, you would pass the response headers a little bit differently by going to the library and adding a comma instead of making a hash of all of the configurations. Now, finding the configurations is still a little tricky with OpenTelemetry. You may need to actually look inside the code of the gem to find all of the available options, which is the case with rack. There are some gems where we have the configuration options defined straight in the README, but this is kind of part of OpenTelemetry. Is there's a little bit you have to do yourself and a little digging you may need to do at this time. So these are all the possible options that you could use. I'm hoping that we'll get better documentation someday, but this model is pretty consistent for every bit of instrumentation. So if you find the instrumentation library, so in this case rack, it usually has a bit of a repeated structure to get to a second instrumentation RB file that will include these options. Whoops. All right. Okay, now we are finally ready to start our Rails server because we have added our instrumentation, so we should automatically get some data that runs. So you can start your server, and if you want to, click around in the UI. That will be helpful to kind of see what's going on in the application firsthand. But just as well, you can call script /traffic. Oh, I'm sorry, that's wrong. .sh rather than .rb, and get some traffic as well. So while we're doing that, I'm going to make a few updates to this, go through some of our steps again. So we'll add our gems. The nice thing with bundle add is you don't have to run bundle again afterwards, but I do here. So these are the 3 gems we're working from right now. Go ahead and bundle. Once I cd into the hike tracker. And while that's running, to go back a step, we're going to add the OpenTelemetry initializer. Call the configure method, add our service name, add our service version, and also add our instrumentation. What is going on? Bundler is very sad. I was afraid about that. Okay, well, we'll just keep using the slides. Has everyone else been able to bundle? Are you guys having problems with the internet? Okay, some problems. It's sending. Okay, it's thinking. Hopefully one person at each table has it. Maybe you can share some screens. Let's see. So I'll just hop over to instrumented then, since we're having trouble bundling over here. Fun fact, underscore is before dash in the alphabet. So that's why these look different. What am I doing wrong here? Thank you. Okay, so hopefully when you started your server, you saw all of these verbose logs with information about each piece of instrumentation that was installed. And even though it's not on this OpenTelemetry initializer, I guess I might as well open the other one. Woo. All the answers. We added this allowed response headers configuration option, and you can see right here that it was in fact applied. And so that's a really helpful way to verify that your instrumentation configurations are working, because a little typo can cause problems. And oh, we're getting some errors with SSL. So I will just go back to my handy dandy screenshots and use those instead. So if I was running traffic, and if we were able to go to a UI and the traffic had been running for about 30 minutes, we would see something really nice and fancy like this. I think it'll be a lot more limited on your application. This is just the home page for the hike tracker service in New Relic. Actually, you know what? Will this work? So this was some traffic that I ran a while ago. We're thinking we could not retrieve this info. Okay, we'll just keep using this. So what this helps show you is just kind of an overall sense of the health of your application. You can see if you've had any major changes in your response time or your throughput. The error rate on this app is bonkers, because there is a random error that gets generated every time you visit the activity show page. And hopefully your error rate is a lot more flat than this. The next place that I want you to go in the UI after you get to that summary page is distributed tracing. So this is where all of your traces live. And you can see each one of these kind of chunks down here represents a different route. So this is great because OpenTelemetry just gives you all of this. And when you click on a particular trace, you can see a little more closely into, instead of just like the overview, the summary, one specific trace in time that you generated. And when you open up the view on that trace, all of these little steps down here are different spans that were created by your instrumentation. Since this one has an error, we'll take a look at the error. So we know here that it's a contrived kind of fake error, but if you had a real error, it would exist on usually the span that created it. In this case, it's that root span. And then you could get more information about the message and try to help solve the problem by being able to see that specific request that happened in the wild that's related to this error, rather than, kind of digging through Rails console logs and maybe trying to parse the information that way. Oh, here's a healthy one. So we can see there's also still a lot of uninstrumented time here, and that could be a place for you to add custom instrumentation, which we will do so in a minute. So custom instrumentation is what we refer to things that the kind of standard semantic conventions don't automatically cover. It's usually methods unique to your domain, and we recommend that you make calls directly to the OpenTelemetry API in order to do that. So what we're going to do is record a span for something specific to our domain in an uninstrumented method, and then add custom attributes to a current span elsewhere in the application. The first thing we need to do in order to do this is create our own tracer. So inside this initializer file, below the configuration block, I'm going to recommend that you add an app tracer. You can save it in a constant. You also don't have to, because OpenTelemetry will register all the tracers by name. So anytime you call OpenTelemetry tracer provider tracer with the same string, you're going to get the same tracer. This just makes it easier. I think there's probably a better Railsy way to do this, but this is the way that I generally do it as I'm trying to debug problems. The next thing we're going to do is we're going to use that app tracer inside of the activities model. If you look in the activities model around line 13, there should be a duration method. And in that method, we're going to add a call to the inspan method. So that's the same thing that we saw in the instrumentation earlier. So you call that tracer, .inspan, and then you give your span a name. So this is the only required argument for your span is a name. Since it is a custom span and custom instrumentation, you kind of have choice over what that name looks like. Since the queries that we looked at earlier, usually like model name query, I thought activity duration could be a good situation here. And since we want to record this whole method, we start that at the top, open up a block, and then add, leave the original code here and add an end at the bottom. So in this inspan method, it will add a span to the existing trace, so that existing overall journey, if there is one that exists, and if it doesn't, it will start a new trace. You can also add attributes to the span to get some more rich information, and there are a lot of other arguments available that we won't go over today, including span links and span events, span kind, like we mentioned earlier too. If you wanted to add some attributes, you could, potentially for this method, add the end time. Maybe you're curious if there is an end time or want to do some kind of rounding about the end times. And in that case, you would add a new keyword argument, attributes, that has accepts a hash. And the key value pairs in this the keys must be strings. Unfortunately, OpenTelemetry is not quite like Rails with hash with indifferent access. You need to use strings for keys in all of the situations. This is for performance reasons. We want things to be really fast with instrumentation. We don't want you to notice the instrumentation or have that add overhead to your application. And this is the way that we found to do that the fastest. There we go, another reminder. So you've added your custom span. Restart your server because we added something to our initializer, so I don't think it will hot reload, and then generate your traffic using script traffic sh in another terminal, or just continue to click on data in the UI. I'll give it another try. Let's see if we have any updates. And if you're doing this on your own application, I would say think about, if you are using a current observability vendor and maybe see a lot of uninstrumented time, add a custom span to that. If you are, if you have maybe some queries that are kind of complex but are also referring to other parts of your code, that could be a good opportunity to add an additional span. Things that are, done by Active Record and MySQL, Postgres, Trilogy, etc. Those will be captured by spans already by instrumentation, but it could be interesting to just throw that a new span into some of your domain logic to see how that changes your traces. All right, we're still out. That's okay. But we should be able to look at that. Oh no, I forgot. I'm sorry. All right, cool. So let's look at our pre-recorded span and back in slideshow mode. So I don't know if you can read this and see this down here, but we now have in that same activities ID trace that we looked at earlier, a new span for activity duration. And that it occurs after the user query. We can see where in this overall journey that method is actually getting called. And that just adds a little more color to what's going on here. It looks like I did not capture the custom attribute here, so we won't see that over there. But if you did choose to add the custom attribute, it would be on this side. So let's add a custom attribute to the current span now. This is another way, if there's something that's going on that you need some domain information that's more specific, that's outside of the semantic conventions, that can be a great opportunity to add attributes. In this case, for our application, we're going to do it through a before action. If you go to the activities controller, I'd like you to add a before action. It's called add location attribute to span. Very clear what it's doing. And for the purposes of this demo, let's add it only to the show route. And then below the main bulk of the controller actions in the private section, I create a new method that's called add location attribute to span. In here, we're going to call the OpenTelemetry trace current span method. So this one is a little different than the method we looked at before. We're not using our tracer, we're using the OpenTelemetry trace API. It does a lot of context management for you, and so it will kind of track behind the scenes what the current span is and attach to whatever is going on at the moment that this method is called and add attributes to that span. So since the tracer is looking at like the overall picture of your application, this like OpenTelemetry trace API, that's why we leave the current span out of the specific tracer. So yeah, so this is an attribute you could add. You could add a different attribute if you like as well. We're not being super concerned about query performance here. And so yeah, so restart your server if you've added this. And I believe that in the course of your traffic script, it'll hit that show page for the activities. So you should start to have some traffic generated. I think I've also been blazing through, so I'm going to give a minute for everyone's UIs to catch up. If you are able to use the UI, I think it can often be a little slow to actually load the data and get it in there after we generate it. Mm-hmm. What? Oh, where are you supposed to see the traffic at? So if you are using New Relic, you should see the traffic in your services view. I think there's probably one more page before that that has all of the different entities that are available to you. And you should see Hike Tracker somewhere on that list. I think that's usually your home page or landing page when you get into New Relic. And then, and then from there, you should see your traffic on that Hike Tracker entity summary page that we were looking at before, which lives in a slide somewhere. Go back a little bit. Yeah, so this would be the home page. And so you can see that the traffic is connecting and that the application is connecting to the back end by kind of seeing a chart, probably not quite this robust, maybe just a couple of little dots here and there to see data coming through. Does that help? Okay. Yeah, any other questions while we're pausing for a minute? Yeah. So there's not a clear, I guess, yes and no. So semantic conventions has opinions for a lot of attributes in certain categories. And you can look at the semantic conventions documentation or repository to get those. Whoa, sorry. But if you're not going to use that, I will just generally look at semantic conventions to kind of get an idea. I think things are often scoped with, if you're going to think about like a hash that has nested keys, everything is separated by a period. That's, I think, the most common way. Yeah. Mm-hmm. All right, let's get back to it. All right, so if we have done this all and everything is cooperating, we should be able to go to one of our newly created activities traces, which would be near the top of your traces when you click into them, and take a peek at the attributes for the route span, which is the span at the top, and see your activity trail location attribute over here. So what we could do with this, if I was playing around in the UI, is that you could start to query for your different activity spans and maybe facet them by location, add some counts to see which locations are the most popular. Maybe that could help you prioritize which locations you want to improve documentation for. This, yeah, activity trail location is very small though. Yeah, so that was kind of seen as the first half. I think at this point in time, we can take a break and get back into it talking about metrics, logs, and active support notifications afterwards. So I think 10 minutes, and I'll be up here if anyone has any specific questions. You can either raise your hand and I'll come over to see how things are going, or come up and find me and we can talk about that too. I don't have a fancy timer though, so yeah, that'd be great. 10 minutes. Thank you. Cool. Okay, I hope that break was helpful. Is everyone feeling ready to move on to the next section? We're good? Cool. All right. I learned some things during the break about how things are going. Sounds like most people are in a good spot. New Relic entities are maybe having trouble getting connected in some places. Some things that helped. So I have my New Relic license key saved in an environment variable that's in my my Z shell config file. If you don't have that, just add the API key directly. You don't need any quotes or anything like that around it. Just kind of formatting it like that will be fine. Just don't push it up. The other thing was that there are some errors that are coming up, and I completely forgot to show why those are happening. So in the app controller's activities controller, I have hijacked the show action to generate an error 30% of the time. So there is a random number between 1 and 10 that'll get generated. If it's less than 7, we'll show the show page. Otherwise, we'll raise this bad luck error. This is a strategy that I use a lot as an instrumentation author to kind of make sure I can see what the state is when errors are raised and make sure things are getting attached to the right spot. Errors and tracking errors and trying to resolve errors is a really common use for telemetry, being able to track error rates and things like that. So I hope that this helps you see the way that OpenTelemetry is kind of automatically capturing your errors. Okay, so we're about to get into metrics. Are there any other questions about the traces and exporter and instrumentation part of things before we go forward? We'll also have time for Q&A at the end. I think we're doing pretty good on time. All right, let's continue. So, all right, metrics. Metrics are in new gems. Like I told you before, metrics are not yet stable. They're still technically in this experimental state, but that doesn't mean they're not usable. It means they're usable with a small level of risk. To add them to your gem file, you can do this here, bundle add OpenTelemetry metrics SDK, or bundle add OpenTelemetry exporter OTLP metrics. One thing, in case you bundled before and are using the instrumented version from before, there were earlier versions of the gem that were installing the metrics SDK from a bug fix branch. That bug fix has now been released, and so hopefully you're getting version 0.7.3 installed. If that's not the one that's installed, you might see an OTLP exporter error. There's not actually a problem with that error coming up besides it being annoying. Your data should still be sent. There was just an issue if data wasn't collected for an interval, that error message would pop up. So install these 2 gems. Now what's going on here is very similar to the tracer provider. There's just a few other terms going on with metrics. So we have a metrics exporter that gets initialized from that automatic OpenTelemetry SDK configure method that's already in your initializer. Instead of processors, metrics have readers. That's what they're called. They do pretty much the same thing. They prepare the metrics for export. They, in this case, with the periodic metric reader, have a specific interval that they go through before they collect all the metrics. And you connect them through your meter provider, which is responsible for creating meters, tracking metric readers, very similar to the tracer provider. So this is not code that you need to add. This is what's happening when OpenTelemetry SDK configured is called by default. And similar to traces, if you wanted to add a console exporter, the environment variable is the same. I don't think I have a slide for that. It is just OTel underscore metrics underscore exporter as the environment variable is equal to console comma OTLP. Just sub the word traces for metrics. So the metric structure from that configure method, create and set a global meter provider. The meter providers are an entry point for the API. They provide access to your meters, and they keep track of metric readers. Now, since metrics are structured a little differently from traces, the way that meters work is meters create instruments. That's kind of, if you're used to using an observability vendor of a different sort, usually I think of an instrument as just a metric. Instruments provide measurements, so every time an instrument is called, you get new data points for your metric. And then the metric readers connect to exporters. Oh, and they don't prepare spans, they prepare metrics for export. This is an environment variable I'm going to suggest you change for the purpose of this workshop. So by default, the metrics exporter runs on an interval of 60 seconds, but that will be a long time in conference time. So this is set in milliseconds. So if you change it to 3,000 milliseconds, 3 seconds, you'll get a lot faster feedback in New Relic or your other observability backend. I would recommend adding this wherever the rest of your environment variables are, either in the initializer or add it to your list in front of your server command. All right, so we have configured our meter provider. Now we're going to create a new meter. This might look familiar. This is very similar to the tracer provider setup, just kind of sub tracer for meter. You might notice that this one is not a constant. We're just using a local variable here. I think I'm very open to ideas about where the most Railsy place is to organize all of your different metrics. Metrics are still pretty new. They are not fully spec compliant, unlike traces. So in the SDK, everything that you see in the specification for traces should be available in that SDK gem. For metrics, we're not quite there yet. We're getting a lot of features, but some of the things in the specification aren't there yet. So all of that is to say that I've just been defining all the metrics in the initializer for now, and then calling them in different places of the application. So the actual instruments that we create, that's what will save as constants instead of the meter. And like with the tracer, make sure you do this outside the configure block. So a little more into OpenTelemetry instruments because they're kind of unique. One instrument is one metric. OpenTelemetry has 7 different types of instruments. And unlike at least New Relic's traditional Ruby agent, you can have attributes on your metrics that are known as dimensions. I'll do a little walkthrough of the different instruments that are available and kind of places where they are used in the OpenTelemetry semantic conventions. So with a counter, you can make non-negative increments. So monotonically increasing counter. This is used in the semantic conventions for process CPU time. So tracking CPU time, every 60 seconds kind of by default. Histograms are best for arbitrary values that are likely to be statistically meaningful. The metric that I think about in this category is HTTP server request duration. This is a metric that we're going to generate later on. So that's, the duration of each of your requests, keep those as a metric. You can kind of look at averages and buckets over time. Gauge is the next one. That's for non-additive values. It's kind of like subscribing to a change event in order to capture some number. Up-down counter is another one. It can have increments and decrements, unlike the regular counter. This is used in the DB client connections count metric, so seeing how many connections are active. Oh, and going back to gauge, that is used in container CPU usage, so metrics specifically for your containers. There are some more instruments that are very close to getting released, asynchronous instruments. So you can have an asynchronous gauge and counter and up-down counter. So keep an eye out for those. The way that those work is that on every interval, it will make an observation instead of recording the metric, and will basically just run whatever callback you provide it and take the measurement from that point in time, and also the attributes from the result of that callback. So what we're going to create first is a counter. We're going to call it the height counter, and it's going to keep track of activities that have been completed. Whenever you create an instrument, it needs a name, a unit, and a description. Now, the unit and description can kind of be whatever you want when you're creating a custom metric. Usually it's something like seconds, milliseconds, so that you can keep an eye on things. This information will be included in the data points for your metric. So it's another way for you to help slice and dice the information to answer questions. And by saving it as a constant, we'll be able to access it elsewhere. So the place where I want us to call, actually, is everyone good with the counter and creating this counter? Wait a second. Okay. We're going to call this counter in the activities model as an after save action. So we'll create a new method called count completions and add that to the existing after save callbacks. We're not going to do anything with this method if the activity is still in progress. On the activities model, there's a Boolean in progress. It should be true as long as there's not an end time. If there is an end time, then it's no longer in progress. And on this height counter, we're going to call the height counter, and with a counter, it has an add method. Different instruments have different methods. So for example, with histograms, you don't add with them, you record. And since this is saving a single record, we're going to add 1 to our counter and then provide it some attributes with potentially some PII, and grab them to take a look in the UI and kind of look at how completions are going based on these different dimensions. So if you haven't already, once you've added that information, restart your server, rerun your traffic. And the thing that is different about this is that the traffic script is not, particularly helpful for this step. The reason being that you do not have the completions button doesn't really get pressed in that traffic script. So let's see if my server will start, even without OTel. Oh, because I broke my thing. Let's see. What else is wrong? Has everyone had an okay time installing the metrics SDK? Is it working? Okay, there we go. So we'll hop into localhost. And I did not freshly bundle before this, so you can see all my example activities. I'll make a new one and select a user and a trail And it's marked as in progress, so we'll create that activity. And then when you're on the show page for an activity that is still in progress, this mark as completed button is there. And clicking that button will call the place where we added our metric. So provided that's all worked out and everyone's UI is cooperating and ingesting data nice and fast, you can see this metric by querying. So in New Relic at the very bottom, actually let's look at an old screenshot. The very bottom of the page, you can see this query your data. Go ahead and click on that, and it will pop up a window where you can query the data specifically. Okay, and so the way that you can see this activities completed metric is by, let's see, no, that's not going to zoom. So the metric is from metric, so from that data type that we have just sent over. Select star if you want to see all the dimensions that are available. That's usually how I like to get familiar with a metric. And then where the name of the metric, in this case, activities completed, I believe it can be wrapped in quotes or backticks, is not null since 48 hours ago. You don't need to make that window so long. You can make it shorter. I think by default it's 30 minutes, so everything that you've recorded should show up. But yeah, for every click, you should see a metric recorded here. And taking a look, we can see here in this activities completed section, the counter value that was provided, and also the type of instrument here. This type count shows that it was a counter instrument. And over here, I forgot to scroll in my screenshot. You can see the location. You should be able to see the other dimensional attributes that we added too. Do I have, okay, I don't have any other ways to dice the data here, but with this querying tool, it's called NERCL. If you want to kind of alter the data and keep playing around with it, you can add a facet call after where, and maybe facet by location. That will give you an option. If you click on this area, chart type over here, you can see a different chart and kind of see that data displayed in different ways. This will be different on every observability provider. All right, let's get into logs. We will come back to metrics in a minute. So logs is structured very similar to traces, more similar than metrics are to traces. There's a global logger provider that gets created and set when that OpenTelemetry SDK configure method is called. The logger provider is an entry point for your API calls. It provides access to loggers, which create log events there's essentially one event per log entry, and keep track of log record processors, which prepare the log events for export. The terminology around logs is a little different than tracing. We always call the information that collects traces instrumentation, and that's still where my brain goes with logs as well, but OpenTelemetry refers to instrumentation as bridges. So you can take existing logging frameworks and add new bridges either inside of their code or from maybe an OpenTelemetry additional gem for existing frameworks to kind of translate that data into logs that are OTLP compliant. What's nice about OTel logs is that they are dimensional by default. There aren't any required attributes. Message is just one attribute of many. And two of my favorite attributes that exist on OpenTelemetry logs are trace ID and span ID, so that way you can correlate your logs with your trace and span events to kind of get a better picture of how these things connect, how your logs, what logs were being actually emit in your console when that specific trace was running. So in order to install logs, we're going to do some fun stuff. We're going to comment out the OpenTelemetry instrumentation all gem and install a new version of it from my fork. What we're going to do here, this is all available in that instrumented gem file if you want to copy and paste it. The reason why this is from my fork right now is that this code is in a PR. It has been reviewed by some of the maintainers, not by enough of them yet for us to merge it in. So hopefully soon you won't need to install it from source. But what this instrumentation is doing is that it is adding a bridge for the Ruby logger gem. And the Rails active support broadcast logger, that's the logger in Rails 8. It's named something slightly different for older versions of Rails. It leverages Ruby's logger library to generate those logs. So in this case, by instrumenting Ruby's logger, we're able to get the benefits in Rails and kind of have all of our logs automatically translated into OTel and sent over. I believe I'm missing a slide here too. If you look at that instrumented gem file, there are 2 other gems, and I think this is on the gist that you need to install. The OpenTelemetry logs SDK and the OpenTelemetry exporter OTLP logs. So very similar naming scheme to metrics, but since this code is not yet stable, it is in its own gem. And unlike metrics, the logs SDK is feature complete. We just need more people to use it and know that it is working well in their environments before we can graduate its stability status. So please bundle to install those gems. The next step is to update the default logs exporter. So currently by default, the logs exporter is to the console instead of over OTLP, but we want it to be over OTLP so we can see the logs in the observability backend. So I recommend adding this. And you can also, like with traces, console, OTLP, if you want to see them both. And that's it for logs. By calling that configure method, it should all be set up and making sure that instrumentation is installed. Hopefully by using use all. If you are just calling the use method instead of use all and installing each individual gem, you will need to add a use call for logger. So restart your server, run your traffic. And hopefully, if you're able to get into your New Relic entity, you can hop onto the logs tab inside of that APM and services section and should see all of the logs that are coming through for your application. And hopefully it will look pretty similar to what you're seeing in your Rails console as well. Some of the differences, though, when you actually click into the log, you'll see all of these other attributes that are included as well. So, in this case, New Relic, I believe, is adding this entity GUID and GUIDs. You have the message, like I mentioned earlier, which is what you'd see inside of your Rails console. We can see the provider of the instrumentation was from OpenTelemetry. Let's see, what else is fun in here? Some of these process and service details are related to that resource that we looked at earlier. So we can see that service name and version that we set. It has the severity of the log and captures that. OTel also translates logs into specific severity numbers that are different than the way that Ruby tracks its severity numbers. So I don't think 5 is a valid severity number, and you probably haven't had to deal with Ruby severity numbers unless you're diving deep into the Ruby logger internals. But my favorite attributes, like I mentioned before, are span ID and trace ID. So from that, we should be able to go to the specific trace. Hopefully in your example, up in this distributed trace section, you have one that you can hop to. And then on that trace, you would see this logs tab with a number next to it. And then be able to click on that and see the logs that occurred during that point in time. So that's giving you more dimensions, deeper knowledge, a larger ability to answer the questions that come up when you're trying to solve problems in your code. All right, we've graduated to adding our own instrumentation for something that OpenTelemetry does not have available yet. So soon, instrumentation will emit metrics. It does not today. But there are a lot of great metrics that are already defined in the semantic conventions that you may want to take advantage of. This example is going to be a little bit contrived because I would probably add this specific metric in a different instrumentation library. But since this is RailsConf, let's use Rails active support notifications and add a histogram. If you want to follow along with the specs, I think this link is in the gist. We're going to look at the HTTP metrics semantic conventions now. So let's see. Wonderful, it's open. So if you want to dive into the semantic conventions, if you're on the OpenTelemetry docs, then you can find the section under specs. Semantic conventions are nested in here. This next level is kind of all of the different categories that OpenTelemetry has conventions. Now, when you see this status mixed, that means some of them are seen as stable and have been released. Some of them might be in development or experimental. And when they have that in development or experimental label attached to them, they could change. But there's this great in-depth description here to try to facilitate that change in the case where there are things that are outdated or not the new stable conventions to a stable convention. And we're starting to roll this out for traces in some of our instrumentation libraries, this semconf stability opt-in environment variable. It's a little out of the scope of what we're talking about today, but essentially, when you see this, you have the option to emit the old attributes, the new attributes, or both. And if you're just starting with OpenTelemetry and adding this to your application, I recommend you start setting this environment variable, at least for HTTP, since we're starting to add it to more and more of the libraries, and setting it to HTTP here, so that way, for the libraries that are compatible, your attributes are going to take the shape of what is going to be the stable semantic convention, so that if you're setting up queries and dashboards and things like that, you're not using the names that are going to change. You're using the names that will become stable. So that's a little bit of a detour to get to what I really wanted to show you, which is the semantic convention entry for the particular metric. So this is HTTP server request duration. It's a very important metric to be able to track the duration of your server requests and kind of look at averages, how things change over time, pay attention to anomalies. This is a very special span because it has unique bucket boundaries. So histograms have buckets. You can think of them like a bar graph, where each line, each bar is its own bucket. And the default buckets are much larger and not really compatible with what you would traditionally see as durations that would come up in a standard HTTP durations. So we have our name here. There's an instrument type, unit, like we looked at earlier, description, and then stability. And down here are all of the different attributes that should exist provided the data is available on that metric. So we are going to take this and add it to our application. Okay, so we're gonna do a couple of steps in order to add it. The first thing is we wanna take those boundaries that we saw from the semantic conventions page and save them in a variable. These are explicit, you might see this word explicit buckets, explicit boundaries. There's another form of buckets that I believe is out now or will be out soon for the Ruby metrics called exponential bucket histograms. And those are pretty cool. They look at the data that's actually coming through and adjust the buckets based on that so that you can kind of see more meaningful buckets. But that's not the default for this particular metric. So we're going to use this default. The next thing we're doing is we're updating the meter provider to add a view. So metric views in OpenTelemetry are ways to configure metrics to do things that you want them to do that are outside of the default. You can add new aggregations. So if you wanted to try out exponential bucket histograms, you would add a view in order to do that. The views work by looking right here for a name. It also accepts wildcards. So if you have, if you want it to apply to all of your metrics or only metrics that include certain words, you can use that as well. You also add the type of metric you'd like this view to apply to. And then here we're updating the aggregation for histogram. There are other attributes available too for different types of instruments. And then we're applying those explicit boundaries that we had inside of this explicit bucket histogram. So it's all pretty nested. I think the documentation needs to get a lot better for Ruby, but know that if the metrics, like the semantic conventions, if they're not working for you and you intentionally want to change them, or the defaults just in general for the instruments aren't working, this is a tool that you have in order to tweak that information. Now that we've created our view with our custom boundaries, we're going to create the instrument. So at the bottom of this initializers page, we're going to add our duration histogram. Instead of calling create counter, we call create histogram. We'll give it the name that was in the semantic conventions, HTTP server request duration. The unit will be seconds, matching the conventions, and then we'll use the same description, duration of HTTP server requests. And as always, you can copy paste from the gist or the completed instrumentation. This next one's a little longer, a little meatier. So what's going on here is that we're calling active support notifications subscribe, which we looked at earlier, because we want to subscribe to the process action event. So whenever process action is happening, whenever action controller is running through a particular action, we would like this histogram to record the duration. Like I mentioned earlier, we'd probably go lower level and actually put it on the server gem like rack. But for today, this will give us a pretty good approximation of how long things take. What's great about this is that the event payload has a lot of the attributes that we would want to include. And this list is a lot shorter to make sure everything fit on the slide, but there's a more comprehensive list in the completed instrumented version of the application of other attributes that you can look at. One thing to show there too before we wrap up on that step is that sometimes this information is a little bit nested inside of other values that are part of the payload. So the headers actually come out as like a rack headers object, and you need to dig inside of them to get the specific values. Sometimes as instrumentation authors, we have to do funny things like manipulate even still those values to get exactly what we want in terms of protocols, in terms of attributes. So going back here, the last step after we've collected our attributes is to actually call record on that histogram we just created to give the event duration as the value that we'll capture, and the attributes is what we've collected above. So now every time process action runs, we'll record this duration histogram. So you can restart your server, and this should, generate a new, or I should say, record a new measurement for this instrument every time any controller action is hit. And once you've generated some traffic for a while, I think I May have forgot to mention this earlier. There's this toggle at the top to view charts based on metric data or span data. So if you've been viewing it based on span data, or up until this point just metric data, it probably looked very lonely. And now these graphs will start to have a little more life. And then if you'd like to query, kind of like we did with the previous metric, to take a closer look at what's going on in this particular instrument. Similar to the last query, from metrics, select star, where HTTP server request duration is not null. Since 30 minutes ago, you can leave that out as well. And when you run that, depending on how much traffic is generated, you'll get something that looks kind of like this and has information about that specific method. We can see our 404s are different than our 200s when the random errors are raised, or probably in this case when the trail didn't exist. And that allows you to get a little deeper into kind of trends in these metrics by aggregating this data, maybe faceting based on your status code or request method. Oh, I thought I had more screenshots, but I guess that's it. We have successfully gone through the workshop information. There's a little more that I want to still chat about, but that is the gist on what I wanted to cover today in terms of getting the basic signals added to your application. There are more signals in OpenTelemetry that are getting added. Profiles is something that's coming along soon, but I think it will still be a while for Ruby before we actually get around to implementing them. Speaking of which, so hopes and dreams for the project. I am one of the maintainers of this project, and as I mentioned, these things, Ruby's packages are not stable, they're not complete in some cases. So the goals that we've kind of talked about as a special interest group is to move towards metric stability. It seems like there are some people who have a strong interest in metrics. Alongside that, we'd also like to move towards making logs stable, and having those core signals stable would kind of start to put Ruby more on par of some other languages that have more mature OpenTelemetry offerings. I would also like to update the instrumentation to use stable semantic conventions, and the bridge to do that is through that environment variable we looked at, the OTel semconv stability opt-in. Also adding metrics to instrumentation so that way that server request duration metric that we added is generated automatically. File-based configuration is another thing that's been talked about, where you could have all your configuration in YAML instead of needing to actually add an initializer and call Ruby code to update those configuration values. And theoretically, that configuration could also be applied to if you have applications in other languages. Global configs could apply to those as well. And then also, whatever is most useful to the community. That's also something that I would like to focus on. And so issues, pull requests, those are always very welcome. In the GitHub repos under the OpenTelemetry project, the Ruby ones specifically are OpenTelemetry Ruby, which is what includes the SDKs, the APIs, the exporters, kind of those more spec'd out elements of the project. The other one is OpenTelemetry Ruby Contrib, and that one includes instrumentation. It also includes resources, so you can have automatic resource detection for AWS and Azure. There are propagators in there, which we didn't cover today, but they can help support distributed tracing across your services. So pretty much anything that isn't in the specification, something that's maybe more defined by a semantic convention, you can find that code in the Contrib repository. The other things that are important to know about are documentation. There's a specification repo, a semantic conventions repo, if you prefer to look at the information that way instead of on the docs website. And there's also a community repository that includes a lot of information about how OpenTelemetry organizes itself and what meetings are available in order for you to meet with maintainers and approvers in order to participate in the project or get support. Support. Here we are. So if you decide to use OpenTelemetry or are using it already and have questions, the places that I recommend you reach out. First, I would recommend joining the Ruby SIG, the Ruby Special Interest Group. OpenTelemetry calls all of the groups that meet about different languages or different facets of semantic conventions, special interest groups or SIGs. So we meet every Tuesday at 10 a.m. Pacific time. You can find the Zoom link in that OpenTelemetry community repository on the README. An end user SIG, that is another great place for you to join if you're just getting into OpenTelemetry. It's every other Thursday at 10 a.m., not every Thursday at 10 a.m. And they want to know about how the OpenTelemetry information that's available online is working for users and where it needs to be improved, and also kind of help troubleshoot or learn about use cases. The CNCF Cloud Native Computing Foundation is an organization that has a lot of different open source projects, including Kubernetes, but OpenTelemetry is one of those projects. And inside of their Slack workspace, there is an OTel Ruby channel where you can also ask for support or ping on issues or PR reviews that haven't been looked at. Issues or discussions on the repos are another great way to get in touch. Pull requests are welcome. Issues are welcome. My GitHub username is my name, Kayla Reopelle. So feel free to tag me on things if you have any questions or need any support. So if you, okay. So with next steps here, there is a new Getting Started app coming soon that will be available on the OpenTelemetry documentation website that will include some of those advanced concepts we didn't get to today, like span links and custom processors and the collector, stuff like that. So keep an eye out for that documentation. And yeah, that's all I had. This has been a long time, a long workshop. I appreciate you all staying here and hanging with me through it. Does anyone have any questions that you want to discuss? Yeah, kind of as a group. Yes. So the question was, if you already have something like structured logs set up in your Rails app, how do you migrate to OpenTelemetry? What I've heard most people do is kind of keep both tools installed for a while and make sure that OpenTelemetry is solving your needs. Now, there can be some issues with monkey patching and things like that if that's how the logs are getting recorded, if the same method is being edited by multiple sources. But hopefully that's not the case. So just something to be aware of. But I think people will tend to deploy both for a while, make sure that they can answer the questions that they want with the OpenTelemetry data, and then slowly start to remove that from different services. Any other questions? Okay, well, I'll also hang out up here if you do have questions. I hope that the internet worked well and that things were able to be followed for the most part. Like I mentioned, the repository has a lot of open spaces for discussion too. We have an issue specifically for metrics feedback and for logs feedback. So if you are using those things and have questions, that's a great place to ask them. I would also love some feedback on this presentation. If you're willing to share, this QR code will take you to a Google form where you can answer a couple of questions and let me know how I did. So yeah, I am really stoked that everyone came. It's so awesome. So enjoy the rest of the conference. And yeah, thanks for your time.